มาแล้วนะครับ
Recording progress.
And listing extending live stream to YouTube, right? Use this one. Zoom to YouTube. All right. ไปแล้วนะครับไม่ทราบว่าคุณได้ยินหรือเปล่านะครับalright เสียงไปแล้วนะครับ alright everything is fine and we get back to Zoom finish this in make the screen sharing yes นั่นนะครับเหมือนกับกันพลนะครับกันพลที่ครับชื่อโอ้โหชื่อ starting โอ้ไม่ทราบว่าเสียงไปหรือเปล่าครับYes, we are live at the galvanometer, right? For M604, right here. As we have said before, it is the induced force, okay, due to the coil. Let me monitor first. Oh. What happened? And here we have to monitor at this location. Join Zoom with this one, right? Yes, this is the Zoom version, right? ที่YouTube ที่มาจาก Zoom นะครับมีกสิดิตนะครับกสิดิต1 คนครับ and I'm not sure the one directly from the computer view will work well or not. Oh. All right. All right, here. Yeah, this is the galvanometer, right? Galvanometer can be used as either. I'll be. I don't know.การณพลย้ายที่ YouTube ได้ครับคุณพิมพ์ที่การณพลผมเห็นละเข้ามาที่พิมพ์ที่แชทใน Zoom นะครับตามสบายเลยครับมันมี2 ช่องนะครับมันมี2 ช่องใน YouTube นะครับตรงที่ Zoom นะครับผมที่ Zoom เนี่ยผม ขึ้น resolution นะครับเป็น high นะครับผมไม่รู้ว่าได้ 1,000 หรือเปล่าครับมีคน2 คน alright แล้วก็ไม่รู้ตอนสตรีมตอนที่ forward ไปที่ YouTube นะครับจะชัดมากเหมือนกันหรือเปล่านะครับไม่ทราบนะครับyeah I'll pick my okay all right yeah I'm not sure but the screen seems to not so sharp yes galvanometer is used มีอะไรแดงๆมาแชทใช่ไหมแชทมีคุณมาด้วยนะครับall right galvanometer can be used either ammeter right or the ที่นี้นะครับมีสุดมีอะไรอย่างนี้นะครับเดี๋ยวผมขออนุญาตแคปเจอร์หน้าจอไว้ก่อนนะครับ alright and this one moment we didn't get the monitor yet I'm not sure which one is outไปไหมไปครับหน้าจอยังไม่ไปที่ YouTube บนนู้นนะครับคุณอยู่กันก็ไม่บอกนะว่าจอไม่ขึ้นคุณพิมพ์ชื่อกันรวดเลยครับสต็อปผมไม่รู้ว่าก็ยังไม่ไปที่ YouTube ช่องนั้นครับหน้าจอยังไม่ไปครับtransfer everything to this one right this comes down but I'm not sure the voice is work fine or not in Zoom ได้ยินsure whether you can hear me well in Zoom or not but anyway ที่ Zoom นะเดี๋ยวดูแชทที่ Zoom แป๊บหนึ่งครับมีปองโพลมีธนนัทนะครับ2 คนครับ so we go Zoom นะครับช่อง YouTube Zoom เองก็ตามนะครับไม่ทราบว่าเสียงมาถูกต้องไหมเอ่ยเพราะว่าผมเปลี่ยนตัวรับเขานะครับ alright I hope that everything is fine in yes galvanometer is the historical name of an instrument okay for measuring a small electric currents okay small amount okay we would not use because that's the early generation for the measurement device that the human has set up. In it uses the notion you have learned the solenoid, right? The solenoid is the coil with several turns, right? It's a number of turns, right? In this. All right. And the most common type is the so-called the Song-Wan, okay, the Song-Wan galvanometer, okay. I think this is the French name, okay, from he would be from France. In when there is a current in the coil, the magnetic field exerts a torque on the coil, okay, and the torque is proportional to the current. So if you know how much the current flows, you can get the torque from that, right? And how much torque happen will bring the needle, okay, the needle on the monitor of the galvanometer to rotate, okay, and that's the idea. We would consider the angle, okay, angle of rotation or angle deflection in the angle of deflection should depend on the torque, okay, that again come from the amount of current that you put into that galvanometer. All right. Okay, here we will consider first the first application, okay, for the galvanometer, and it's called ammeter, right? Ammeter is the device used to measure the current, okay, which is quite straightforward according to the Bian formula, right? BIAN, Bian psi phi of psi theta, right? It's quite straightforward. คำว่ามีพิมพ์มาที่พิมพ์มาที่ไลน์นะครับมาดูที่ไลน์นี้ออกจิตติพานเรียน YouTube นะครับที่ซูมนะครับเคนะครับเคกับสิริกันพล YouTube เอาผมเข้าซูมหน่อยครับคุณมีอีกไหมเอ่ยหมดแล้วนะครับโอเคนะครับคุณเข้ามาแล้วนะครับแล้วก็อัครวัตร17เอาอัครวัตรอยู่ที่นี้โอเค anyway we go ahead with the instrument that measure the current, okay, is of course called galvanometer. All right, in the essential concept of the ammeter is that okay, you should know the idea of the galvanometer. Okay, galvanometer should okay, I'm sorry, the ammeter is used to measure the current, right? So in ideal case the theoretical ammeter the meter should have zero resistance. Okay, should has no resistance at all. Okay, the resistance should be zero. Okay, it means the internal resistance in the ammeter here, this is the ammeter, R should be the resistance of this ammeter, R of ammeter should be close to 0, or it would be perfect if we have 0 ohm for the internal resistance of the ammeter. And ideal ammeter should have 0 resistance in so that it doesn't obstruct the current at all. Okay, it has no impedance to the flow of the shaft or the coil, okay, or the current, okay, in that branch. Galvanometer can be made into an ammeter. Okay, we can you have G, right? You have G. It can be used as first thing here in this section, the ammeter, and the second one is voltmeter. Okay, the notation of the ammeter is denoted by A with the circle around that. All right. In the next thing, the second thing is voltmeter. Okay, voltmeter is used to measure the voltmeter is used to measure the volt. Okay, the potential difference between 2 points at any 2 location in the circuit. Okay, as you want to see, wherever you want to see the potential in the circuit, so you can use the voltmeter. Okay, we will talk about that later. Yeah, and now we arrive at the first example. Okay, it's better to see. Okay, this one is quite difficult. Okay, because it really goes into the detail of the circuit analysis. In I don't know whether this topic is included in the typical high school level. Anyway, let's do that. Now we consider this branch. All right, this one. In this example, okay, in this problem, let R, the capital R, be a small resistance. Okay, for scaling the galvanometer, and it has the galvanometer has an internal resistance, which is denoted by the small letter R. Okay, small r here, and to support a full scale current. Okay, the maximum current that this galvanometer can measure is called full scale current. Okay, that's the maximum value for the current that this galvanometer allows. Okay, to go into it. In okay, we cannot measure the current beyond this value. Okay, the full scale current, and yeah, that's the basic information. Okay, we have two things. Okay, the first one is the small resistor, which is denoted by R, and our main interest is the galvanometer. Okay, is the galvanometer, which is denoted by G. Okay, but G right now is used as ammeter. Okay, and inside this galvanometer, we have an internal resistance, which is denoted by R. All right. Okay, and R should be quite larger than small r. Okay, because they use the capital version. And yeah, that's it. We move to the next thing. Like this. What is the value of R if we want to use a 25 ohm galvanometer? So what is that? The information they have provided here is this is the internal, okay, internal resistance, okay, which is the green one there. Okay, the green one here, okay, this one, and with 50 microampere sensitivity. So what does this mean? It means it represents this one, okay. 50 microampere is the amount of the full scale current, okay. This is the maximum current that you can use the galvanometer or ammeter to measure, okay. It cannot measure the current above this beyond this value, and to measure a full scale deflection of 1 ampere. Oh my God, what is the what is that? So the range that we can measure the current is 1 ampere, okay, but this galvanometer can allow you to can allow the current, okay, to flow with 50 microampere only. So how could we do that? Okay, we have the device, okay, that can support only 50 microampere. So what is that? 50 microampere. 50 microampere means it's 50 times 10, let's say to 6, right? And ampere, right? It's very tiny. Okay, this galvanometer is very sensitive, and that's why they say galvanometer is used to measure only small amounts of current. Okay, you cannot use to measure a large amount of current. But we will scale somehow in order to be able to measure the full scale current of 1 ampere. Okay, this is the full scale deflection. Okay, that's our target. Okay, the desired value of the current. How could we connect the two things together? Should we connect both things in series connection, or what is that? Series connection, or second parallel connection. Which connection should we use to measure? Oh no, to connect those two steps together? What do you think then? In order to measure the current, okay, by using galvanometer. Oh no, I should use the G. Okay, we have to use G instead of that because the raw material is galvanometer. Okay, we use G instead of A. All right, and yeah, that's the target we would like to know right now. Yeah, the way to do that is where they didn't provide. We have to use the so-called parallel connection. Okay, we have to use these two things. I'm not sure where is the figure. Maybe it's collapsed somehow. Figure 61, and the next figure is 52. Okay, 52 is here. Okay, in order to measure the current, okay, by using the galvanometer, you should connect any resistance with the galvanometer in parallel way. Okay, this is the parallel connection between the galvanometer and resistance. Okay, they just draw the internal resistance, okay, separately. The internal resistance of the galvanometer separately from the actual module of the galvanometer. Okay, this is the module, the block of the galvanometer. Okay, this device is used to measure the current perfectly, but unfortunately, when we have the copper inside the galvanometer, there should be also the internal resistor สำหรับคนที่อยากให้เหมือน605 request บอกว่าให้ผมอธิบายภาษาไทยด้วยนะครับก็คือตอนนี้เราเรียนเรื่องการgalvanometerนะครับgalvanometerเป็นเครื่องมือโบราณที่ผมอินโทรแนะนำคุณไปแล้วนะครับก็galvanometerนะครับสามารถใช้ไปใน2ทางนะครับก็คือใช้เป็นตัว A ก็คือ ammeter ใช้วัดกระแสนะครับแล้วก็ตัว V นะครับใช้เป็นโวลต์มิเตอร์นะครับแต่ในความเป็นจริงนะครับgalvanometerเองเขาก็จะสร้างมาจากขดลวดนะคุณเห็นครับเห็นไหมสีชมพูนี่ก็คือขดลวดนะครับตรงนี้ก็จะมีคอยเห็นไหมครับไอ้พวกคอยโซลินอยด์อะไรพวกนี้นะครับข้างในนี้จะมีลวดทองแดงครับพวกคอยโซลินอยด์มันก็ทำจากเมทัลนะครับพวกคอปเปอร์ทองแดงนะครับมันก็จะมีความต้านทานอยู่นะครับจะบอกว่าแอมมิเตอร์ข้างในเนี่ยมีความต้านทานเป็น0เลยมันก็ไม่ถูกนะใช่ไหมแต่ว่าทางอุดมคติแล้วมันควรมีความต้านทานเป็น0ครับแต่ในทางปฏิบัติเวลาสร้างจริงมันไม่0นะใช่ไหมครับรูปความเป็นจริงจะต่างจากทฤษฎีอยู่บ้างนะครับแต่ว่าก็ไม่เกินฝีมือมนุษย์นะครับเมื่อเราจะดันทุลังใช้galvanometerมาวัดกระแสนะครับเป็นฟังก์ชันเป็นammeter ตรงนี้นะครับโอเค we're gonna use the galvanometer to measure the currents. Okay, and we have to connect both galvanometer and as resistance, a resistor. Okay, in this way, okay, which is the parallel connection. Okay, all right, and yeah. What else? The next thing. ที่ซูมเสียงใช้ได้นะครับโอเคไหมเสียงใช้ได้นะ and what else? ไม่จบเลยเหรอหรือว่าอะไรมันไม่ไลฟ์แล้วอ่ะนี่ alright in yeah yeah you can see the mechanism of this connection. Okay, the parallel connection between connection of both the resistance and the galvanometer. Okay, this is the I total. Okay, the total amount of the current. Okay, flowing through. This is the whole box of your ammeter. Okay, this area. Okay, now your ammeter include this area. Okay, the whole area here is the part of the so-called ammeter. Okay, and galvanometer just locates here. Okay, at the upper branch. Okay, at the upper line here, and a resistor locates at the lower position. Okay, in order to scale. Okay, the whole the ability of the galvanometer to accept or to cope with larger amounts of current, okay, to measure it. All right, in order to make the analysis of this one, okay, one thing you have to know is that whether you measure the voltage across the upper branch นะครับคำว่า branch นะครับในภาษาวงจรครับเขาเรียกว่ากิ่งนะครับเห็นไหมกิ่งข้างบนครับส่วนคำว่าโนดนะครับก็คือจุดเห็นไหมจุดยังไม่เจอโนดนะครับตรงนี้มันก็เจอโนดอยู่ดีโอเค in the upper branch we have a voltage of a certain value and in the lower branch we should have the same amount the same value of the voltage okay because this point has the same node as this one okay this point and this point are the same okay and this point and the lower point are the same okay because there is no resistance or any device during this journey during this route at all okay the voltage across the upper branch should be equal to the voltage at the lower branch all right and that's the idea we reduce it to make the calculation okay what they want to know is what is the small resistor R okay what is the value of R this one what should R be in this this scenario. All right, and yeah, that's it. The case that we have to talk about. All right, I mean, yeah. And as you know, the voltage here is denoted by from the Ohm's law, right? VIR, right? So at the upper part, you have okay. The current can be separated into two things. Okay, the upper one is I galvanometer. Okay, let's say the I passing through the upper branch is denoted by the subscript G. Okay, the capital G, which stands for galvanometer, and the lower one is denoted by simply capital I. Okay, which is the representation of the current, right? But we don't need to say any subscript at all, okay, for simplicity. And of course, the current that is separated to the above direction and to the lower direction, and finally it combines, both combine to each other at another side. And of course, you can see here that there are two relations. Okay, the first one is the voltage across the upper and lower branch are the same, which means if you apply the Ohm's law, okay, the Ohm's law. So Ig, right, I galvanometer times R, which is the internal resistance of the galvanometer, equal to the current in the lower branch, okay, current in the lower branch times the resistor in the lower branch, okay, and that's the first equation. And in the second equation, the relation is the following. Okay, you have here the current flow in this direction, and another one to the upper part, and one part to the upper part, and another one to the lower one. Here is Ig, and here is I, right? And from this point, you can see that there is the relation, right? I should not write down here. I total, they use TOT, okay. I total should be the summation of these two things, right? It goes this way, okay, away from this point or this node. The currents below just go away from this point too, all right? And so it means that I total should be the combination of these two currents. So in mathematics, we would say Ig plus I, right? So we have two equations, the first equation, the second equation, and let's get into our target. They would like to know R, right? What is the value of R here? And small r is the internal resistance of the galvanometer. They say internal resistance of the galvanometer is 25 ohm, right? In the what else? Yeah, the information, we write down information, okay, in order to solve this. The capital R is what we would like to know, and internal resistance of the galvanometer is 25 ohm. Okay, R is 25, small r, right? Small r is 25 ohm, and the sensitivity means Ig. Okay, when they say sensitivity here, sensitivity of 50 microampere. Okay, all right, yeah, it means it's Ig. Okay, that's equal to the value of Ig, I with capital G. Okay, that's the maximum ability of the galvanometer to accept the current. Okay, so it's 50 times 10 raised to negative 6 in microampere. 10, oh no, it's 1420, right? So 14. We still have 40 minutes left. The next thing is that they want this ammeter to be able to measure the current of, what is that, 1 ampere. So the current here should be 1 ampere, okay, not this value, okay, not this one, okay, or not this one, okay. IG is not 1 ampere, okay. IG is the maximum allowable ability of the galvanometer to accept the current, okay. It's not right, it's only 50 microampere, but the total current that the whole structure here should accept the current should be 1 ampere. So I total is 1 ampere, right? So now what we have is, there are 1, 2, 3, 4 variables, right? And 5 variables with 2 equations. So let's substitute everything into the first equation. IG is 50 at 10 to negative 6, right? 50 times 10 to negative 6, and times R, right? R is the value of the internal resistance, which is 25, and equal the right-hand side. IG is the I total is 1, right? But we would like to know IG is known, I total is what we don't know yet. And yeah, we will substitute everything into this one. All right. In I total is number 1. All right. And IG is the maximum allowable capability of the galvanometer, which is 50 microampere, right? 10 to negative 6, and time, oh no, not times, plus I, right? I is the current in the lower branch, okay, that passes the additional resistor, the capital R, right? So in this case, you know already what is the value of I, right? So if you solve this equation, okay, just move 50 times 10 to the negative 6 to the left-hand side, you would get the value of the current in the lower branch, and it's going to be 1 minus 50 times 10 to negative 6, okay, and that's the unit in ampere, right? That's the current in the lower branch. Now we get to know the value of the current below. All right, so that would be sufficient in order to go ahead with equation number 1 on the right hand side. Okay, I is that value, okay, which is quite long. It's ผมไม่น่าเขียนชิดเลยนะครับ right. Reference IG is 50. IG เหมือนอินสตาแกรม time 10 to negative 6, and R is 25 ohm, right? It's 25 equals the small I, capital I, without any subscript. It's 1 minus 50 times 10 to negative 6, and times R. All right. Oh, R is what we don't know, and we would like to know, right? In yeah, leave the R here. All right, and you move this part, all right, to the left hand side. You get the value for the R, right, which is right now 25, right, in 50 10 to negative 6, okay, and divided by 1 minus 50 times 10 to negative 6. All right, and you just leave it into the calculator. I'm not sure whether it's a nice number or not. Yeah, I'm not sure whether it's a beautiful number or not. All right, yeah. นะครับคุณก็มีอะไรเกิดขึ้นที่สูงอะไรไม่รู้ all right, yeah, you just use any calculator in order to see this one, right? Yeah. Right. 35 times 50 times 10. This is to the negative 6, right? And divided by 1 minus 50 times 10 to the negative 6 again. All right, right there, and you save it and you generate the results. All right, hope everything is fine. Oh, yeah, that's the answer. 0s, 2 zeros, 1 to 501, right? It's equal to what is that? 0.00 12501 12501. Okay, all right, and the unit of no. The unit of this resistor is in ohm. Okay, so you should find any resistor of this value. Okay, which is, what is that? If we write it perfectly, it's equal to what is that? It's equal to 1.2501 milliohm, right? Milliohm, because it's multiplication with 10 raised to negative 3, right? If we move the full stop or the point here 3 times, okay, it's going to appear here, right? It's 1.2501, and it's milli because it's 10 raised to negative 3. So you should find any resistor of this value, and the problem is that there would not be exactly 1.2501 ohm, okay, for the resistor you can find on the market. Okay, so we should use the approximate value only, okay, which is 1.05, okay, milliohm. All right, and I hope that you would get the idea, okay, how to apply the galvanometer to be used as the ammeter. Okay, the ammeter is used to measure the current. Okay, when the current flow here, part of it is flown in the lower branch, part of it is flown in the upper branch, like that. And okay, this branch, okay, this resistor is included in order to support, okay, a partial amount, okay, an amount of the current apart from the actual current, okay. And yeah, and when the current flow maximum, the IT should be the maximum value, and the needle in the galvanometer should stay at the maximum point. Okay, that's the full scale value of the galvanometer. Okay, if you let the current flow a little bit, okay, but not of the maximum value, the needle of the galvanometer is going to point somewhere there. All right, okay, it's not on the full scale, okay, but when we reach the 1 ampere, okay, at the total branch here, the needle in the galvanometer is going to point in the full scale, but actually the current flow in this branch is only 50 microampere only. All right, นะครับเพราะอาจารย์ครับว่าใช้galvanometer มาแปลงเป็นวัดกระแสนะครับแปลงเป็นแอมมิเตอร์นะครับใช้ยังไงครับจับมาต่อขนาดกันsorry sorry for that ขออภัยครับตามครับall right I hope everything is fine right now we go ahead with the next application of the galvanometer ครับคุณก็จะเห็นประโยชน์มากที่เรียนใส่ทำไม all right yes we go to the next page which is another application of the galvanometer okay as I told you before the galvanometer can be used either as either ammeter or voltmeter. Now we will consider this one. Okay, the voltmeter. Okay, you know that voltmeter is used to, as the name suggested, voltmeter is used to measure the voltage. Okay, for example, if you have resistor and flow, there is a current flow like this. Okay, that should be voltage, and you connect the voltmeter to this one. Okay, let me summarize something to you. Okay, ammeter is used to if you want to use the ammeter, you should connect it in series way. Okay, and the voltmeter should be connected in parallel way. All right. Yeah, you should connect it in parallel way. Okay. And you may say, here is the parallel connection. No, I mean, this is the whole ammeter. Okay, this is the whole ammeter, and in this area, it's the whole green that area here. Okay, is called ammeter. Okay, you just move the whole stuff here, okay, to points here to be any point in the circuit, but you have to connect it in a series way. Okay, for example, if you want to see the current in this branch, you have to use the scissor, okay, to cut this point, okay, to cut it. For example, here, if you want to see the current flow flowing in this branch, if you want to know IA, for example, right here, you have to use the scissor to cut the conductor here at this point. Okay, we open this circuit, and you just pick up two things, two nodes here to be at this location, and you will get the ampere. The ammeter inside into this branch. Okay, all right. Green one. Okay, you would have ammeter. Okay, the whole structure there. All right. Yeah, the ammeter is the green area. Okay, it's everything in this green area. You have to connect it in the series connection to any branch. Okay, but in order to measure the voltage, you have to connect the voltmeter in parallel way. Okay, this is the parallel way of connection, parallel connection, because you leave two nodes. Okay, you didn't cut the branch at all. Okay, unlike this one, unlike this way, you cut the branch and you just insert the ammeter into that branch. Okay, that line, it means it's the series connection. But in this way, you didn't cut anything. Okay, you didn't disturb the branch at all. You just connect or add two additional points to the whole branch. Okay, across this area, the area that you would like to see the voltage. Okay, let's say this is IB. Okay, and let's say this is RC. Okay, so the value of the voltage that we should be able to observe in this voltmeter should be the product between IB and RC. Okay, the value between IB and RC should be observed on the monitor of this voltmeter. ไม่รู้ว่าคุณจะได้มีโอกาสทำแลบบ้างไหมนะแล้วก็จะได้สนุกนะแล้วก็จะพบว่ามันไม่ตรงตามทฤษฎีบ้างอะไรอย่างเงี้ยเราก็ต้องมันขึ้นกับหลายอย่างครับ บางทีนะครับตัวต้านทานเนี่ยก็ซื้อมาคุณภาพไม่ใช่ขอบทองเป็นขอบเงินเนี้ยมันก็จะมีความเออร์เลอร์ใช่ไหมหรือว่ายิ่งแยกกว่าเงินไปเลยนะครับความกวัดแกว่งของค่านะครับคือมันจะมีโรงงานผลิตมามันจะไม่ได้ค่าเป๊ะๆนะครับมันเช่น 12K มันจะไม่ได้12มันอาจจะไม่ใช่ 12,000 โอห์มเป๊ะๆมันอาจจะมี 12,000 แล้วก็มี5 โอห์มแถมเข้ามาตรงท้ายนะครับมันก็จะมีบวกลบความผิดพลาดนะครับเนื่องจากโรงงานผลิตเนี้ยก็จะมีความผิดพลาดตรงนั้นนะครับแล้วก็ V ที่โวลต์มิเตอร์กระดิกอาจจะไม่เท่ากับ IB คูณ RC เป๊ะนะครับเพราะว่ามันขึ้นกับ R ที่โรงงานผลิตมาด้วยหรือว่ามันขึ้นจากความเออร์เลอร์ของตัวโวลต์มิเตอร์ด้วยนะครับก็ปวดหัวกันไปโอเคไหมครับเวลาทำแบบว่าเราต้องวัดค่าให้มันตรงตามทฤษฎีนะครับก็ได้ตรงบ้างไม่ตรงบ้างโอเคสมัยผมอยู่ปริญญาตรีนะครับ alright yeah that's the story that you may face with if you study electrical engineering in faculty of engineering. All right, voltmeter. All right, yeah, that would be the complement, right? As you can see here, in order to accept more currents, we use galvanometer, okay, to be connected in parallel way to an additional resistor, which is the capital R, and that's the quantity we have just determined or calculated, right? And in this one, voltmeter, we do it a different way, okay? We are gonna connect an additional resistance, okay? It's not small here, it's is stated as a large resistance, okay? In a series way, okay? What is that? 63 here. Okay, here voltmeter is the whole string can be decomposed into these two devices. Okay, this is the first device. This is the first device. This is the additional resistor. Okay, as we have seen in previous example. And here is the galvanometer. And you may ask me why they write down a resistor in front of the galvanometer. Okay, this is the ideal case of the galvanometer. It has no internal resistance at all. Okay, but in fact, in nature, in practice, we could not do it. We cannot make it. If you can make it, but you have to use this device at the temperature of -40 degrees of Celsius. Is impractical, right? Because we should work in the room temperature, 25 degrees of Celsius and so on. So that's why they write down an additional resistor in front of the galvanometer. This is the theoretical or the ideal galvanometer. And this is the internal. This symbol represents the internal resistance of the galvanometer, okay, inside the galvanometer, because the galvanometer has also a solenoid, right? You have seen in the previous class, we were dealing with we deal with the solenoid, right? And solenoid is made of copper, so there should be also there should be some thing from the there should be some resistance from the imperfect, okay, the imperfect conductor. All right, that's the way we modify. Okay, this is a piece of galvanometer. Okay, let's say this. I write that. This is the ideal. Okay, ideal galvanometer. Okay, this is the additional resistance. Okay, that's the resistor. Sorry, additional resistor. Okay, you add it. What is the reason why we should have this? Because we want to use, we want to modify the galvanometer to be able to measure a larger value of volt, okay, or potential difference. Okay, and the whole thing here, okay, is denoted by a single circle, okay, and surrounded with the letter V at the center, okay, which denotes the voltmeter. All right. now we ทุกคนพอใจนะครับเขาใช้ R นะครับ R อีกตัวหนึ่งR มีขนาดค่าเยอะนะครับเพื่อเอามาผมลืมบอกไปว่าโวลต์มิเตอร์ที่ดีควรเป็นอย่างไรนะคุณทราบไปแล้วนะครับว่าแอมมิเตอร์ที่ดีก็คือควรมีค่าคอนสแตนต์ภายในเป็น0ใช่ไหมครับแต่ว่ามันเป็น0ไหมมันไม่เป็น0ครับเพราะว่าในทางความจริงครับเวลาเราสร้างเครื่องมือวัดนะครับมันเป็น0ไม่ได้ครับมันเป็นได้แค่ค่าต่ำๆโอเคไหมยิ่งคุณพยายามบังคับให้มันเป็นค่าต่ำๆมากเท่าไหร่นะครับมันก็ยิ่งมันจะเปลืองครับเปลืองคือคุณต้องซื้อวัสดุดีๆแพงๆครับมาใช้ครับเห็นไหมก็ว่ากันไปนะครับแต่ว่าif you want to use the typical material in the market, okay, you should accept that there will be something that is not imperfect, okay. เมื่อคุณยอมรับว่าจะใช้ค่าจริงๆนะครับค่าจริงๆในโลกความเป็นจริงมันก็จะไม่เป็น0นะใช่ไหมครับโลกความจริงก็ต้องอยู่กับมันให้ได้นะครับยกเว้นในอนาคตนะครับผมแก่ไปแล้วผมตายหรือผมเสียชีวิตสิ้นไปแล้วคุณยุคใหม่คุณอาจจะพัฒนาเทคโนโลยีนะครับคุณสมบัติเรื่องวัสดุศาสตร์โลกแมทเทียลอะไรพวกนี้อาจจะสร้างเส้นเลือดตัวนำที่มีความต้านทานเป็น0 โอห์มก็ได้นะแต่ณเวลาเนี้ยโอเคไหมครับผมอาจจะเป็นรุ่นคุณปู่สำหรับรุ่นลูกคุณอะไรอย่างนี้ก็ได้นะครับก็มันยังไม่เป็น0โอเคไหมครับก็เรียนกันไปตามนี้ก่อนเดี๋ยวจะถามว่าอาจารย์ที่อาจารย์สอนเมื่อสมัยผมออกไปทำงานอายุ40-50มันไม่เป็นจริงคือณเวลานี้นะครับ at the moment okay okay that's the ideal case for the ammeter. It should have the ammeter, okay, again ammeter should have 0 ohm, okay, no internal resistance at all, but the voltmeter lies in a different idea, okay. The voltmeter should have infinity ohm. What is the reason behind that? Why should we have 0 ohm for the ampere for the ammeter? Because if you want to see the current flow, for example, in this branch, right, and you have to cut it, right? You have to cut it, and you add the ammeter into this location, right? Okay, you just add it to the original branch like this. This is the any value of M, okay, to be measured in if ammeter has an internal resistance, the whole branch should be written like this, okay. Another version of representation is going to be this one, right, and this one, okay. This is the internal resistance of the ammeter, and here is the original resistor in that branch, okay. When you have an internal resistor or resistance like this, it means you disturb the whole branch, okay. And the total resistance is going to be the combination of these one, the small r and rm, okay. So it's not good, okay. The perfect way is that you should have ammeter with 0 ohm, okay, with no resistance at all, but it's not it cannot happen in nature, in practice. And let's talk about the application or how we use the voltmeter, okay. We use this one, okay. In order to use the voltmeter, you just connect it like this, like you have voltmeter and you just do the parallel connection, okay. You just connect it in a parallel way to the original branch like this, and and let's see what the reason why I say the voltmeter should have infinity resistance. It's because we still have 15 minutes. It's because if you have zero resistance in this branch, okay, we can say, oh, sorry for that. We can draw it again like this, okay. And if you draw it, okay, this is the internal resistance inside the voltmeter. Okay, this is small r, this is Rm. Okay, if this one is 0 ohm, okay, if you are current and you want to flow, okay, there are two ways, right? The upper way and the lower way. In the same level path, you have some obstruction, right? But in this part, if it is 0 ohm, there is no obstruction at all. And if you are the current or the short, do you prefer to go to through this branch, which has some obstruction to you? No, you will not go that, all right? Because there is impedance, okay? There is something that try to obstruct your movement. You would prefer go in the upper branch, okay? Because if this one is 0 ohm, right? So in this case, you cannot measure the actual value of the voltage across this resistor at all, okay? If the current just flow completely or 100% in through the voltmeter, so it's wrong, right? Because IR here is the missed value, okay? Is the wrong value of the current flow in this branch, okay? Because to disturb it, the best way is that you should have infinity resistance to this branch, okay? It means it should completely obstruct the current flow in this way, okay? So that the current you just flow in this branch, okay, like the original one without the voltmeter, okay, because you add the measurement device, and the measurement device should not disturb the original circuit at all. Okay, that's the base way. Okay, and that's the reason why I say the voltmeter should have infinity. Okay, if this one is of infinity ohm, it will completely obstruct the current. Okay, and there will be no currents here at all. Okay, I should be 0 to the voltmeter. Okay, so that's the desired property we would like to get from the voltmeter. But in the same way, we could not find the voltmeter with 0 volts. You can find it, but you have to work. Okay, the voltmeter should be made of platinum, and platinum is the rare material on Earth, right? Rare metal on Earth, and it's expensive. It's not useful at all. If you build up the measurement device with something expensive, you would not be able to sell it on the market, right? And the acceptable material on the market is copper. So when we use copper to build up the to be made as the voltmeter, there should be the internal resistance, and it cannot be made to be infinity, right? So now we go ahead with this example. Let R be a large resistance. Okay, that's the additional value of the resistor. Resistance for scaling the galvanometer with an internal resistance R to support the full scale voltage. And what is the value of capital R? If we want to use 25 ohm galvanometer, okay, this is the internal. This is R, small r, right? Small r is 25 ohm. And 50, okay, the same galvanometer, 50 microampere sensitivity to measure full scale deflection of 10 volts, all right? Of course, we have the connection of the voltmeter like this, right? And the current, okay, this is the additional, and this is the internal resistance of the galvanometer. So this is small r, this is capital R, and that's the value we would like to know And in this case, they say the sensitivity is 50 microampere. It means the maximum value of allowable of the current flowing through the galvanometer is 50 microampere. Okay, 50 microampere, and here is 25 ohm, right? The internal resistance of the galvanometer. เมื่อมันลงเตอร์นะครับเตอร์คือตัวต้านทานนะครับถ้าลงแทนก็คือค่าความนะครับค่าความต้านทานนะถ้าผมพูด resistance ก็คือค่าความต้านทานนะครับถ้าเรียกว่า resistor ก็คือตัวต้านทานนะครับตัวต้านทานก็คือไอตัวหยักๆนี่นะครับเห็นไหมyeah, what is the value of R and the full scale diffraction they would like to measure is 10 volt. So what is 10 volt? The 10 would mean the value here. Okay, here should be 10 volt. Okay, during this between these 2 points. Okay, the maximum value of the volts that can happen through this between these 2 points should be 10 volts, and we will 52แล้วครับเดี๋ยวเอาไงดีเดี๋ยวขอจบแล้วกันครับข้อนี้ครับso we apply the Ohm's law, right? So V equal IR, right? And yes, V is number 10, right? And I is IG, right? And R total, right? R total is the combination, okay, the summation between capital R plus small r, right? And you would like to know R, right? So you move 10 by IG, right? And here you have R plus small r, right? If you want to get the capital R, you would see 10 by IG, right? Minus small r, right? 10 divided by IG is 50. 10 less to negative 6, right? Microampere, and minus 25, right? So you put it into the current, into the calculator. Right? You put it into the calculator. You will get the value of the everything, right? It's going to be 19975, okay, 39 ohm, right? And if you convert it to kilo, right? It's 199.975 kilo ohm. Okay, all right. And yeah, this is the value you could not find easily in the market. Okay, if you go to the shop, they will not have the resistor of this value. Okay, the one that is close to this is gonna be 200 kilo ohm. Okay, ถ้าคุณไปที่ไหนที่บ้านหม้อนะครับก็คุณก็คงซื้อตัวต้านทานที่มีขนาด200กิโลโอห์มพอครับโอเคประมาณนี้นะครับอาจจะเซตอะไรเสียเวลาไป4นาทีครับsee you on Friday today. If you have any questions, just let me know. If not, we're gonna leave our lecture right now. มีคำถามไหมครับถ้าไม่เขาก็พบกันวันศุกร์นะครับต้องการให้อธิบายภาษาไทยไม่เอ่ยผมจะได้ใช้เวลาที่เหลือ10ครับอีกประมาณ15นาทีอธิบายภาษาไทยให้ครับมีไหมครับany idea ผมอาจจะไม่ได้ยินนะคุณพิมพ์มาแล้วกันครับถ้าต้องการให้อธิบายภาษาไทยครับไม่รู้ว่าอยู่กี่คนนะครับประมาณนี้นะชัยสิทธิ์นัทโยธินชวินชวามนะครับขุนนะครับเพทราพิเชษพงษ์ธนนัทธินภัทรนะครับทัชกรนะครับถ้าต้องการให้อธิบายภาษาไทยก็แจ้งผมมานะพิมพ์มานะถ้าไม่ก็เลิกเลยนะครับใช่ไหมเพื่อว่าผมจะได้เตรียมสำหรับห้อง605นะครับโอเค there is no response from you at all okay see you on Friday สวัสดีครับบ๊ายบายครับ